Hi everyone, we're going to be looking at structures today. So we've looked at control statements, if else statements, we've looked at functions, we've looked at loops. Now we're looking at we're going to look at arrays soon. That gets a little bit more nuanced and complicated, which also when we're looking at arrays, we'll also look at strings because they're related. This is the last of this sort of simple-ish data types and data structures and sort of programming techniques that we're going to have. So, what the heck is a structure? Let's go back and why is it useful? Why do we apply it? How do we use them? How do arrays and structures work together? We're going to be looking at that, and we'll get to review at least arrays finally again, because we went over arrays very quickly last time around. I want you to feel a little bit comfortable with arrays so you can use them on an assignment, but you won't get into the nitty-gritty details of arrays until we do dynamic arrays and memory allocations and pointers. So this kind of data types we've already looked at. We're not doing pointers yet. We're going to be seeing them soon. We've looked at things like integers and shorts and chars and floats and doubles. And we've looked at arrays a tiny bit. So like a float array, this is me making a float array. It is of size 100, so which is 100 floats all strung together one after the other, and you can get individual elements. I can get individual, for data, I can get individual element 0 in that array of floats by just putting in the 0 here, and that would be 3.432 or something like that. But I want to actually group related data some of the time. So if I have student information, maybe I have a name, an email address, a student ID, a grade point average, for example, maybe a whole bunch of different data. Already with 4 parameters, if I'm trying to pass in some student information into a function and I have to pass in 4 parameters, that's already looking pretty ugly. And although I could make an array of names, an array of emails, an array of IDs, an array of GPAs to have a whole bunch of different students, what I really want is all the information about one student is bundled together. I want all the, and then I would have an array of these bundles, if you will. Right? You don't put all the names together and then all the student IDs together. You put the name and the student ID together. You want to have something that's related to each student, all the information for a particular student, bundled. And if I'm trying to pass in all the student information into a function, I don't want to have to pass in like 25 different variables into my function. I want to sort of pass in the student. So this is the idea behind a structure. Or if we talk about movie information, as another example, what do I have for movie information? I have the name of the movie, I may have the director, I may have the year, I may have the IMDb URL, I might have the Rotten Tomatoes rating, whatever the case is. So let's say it's an array of different array of strings for various actors in the movie. Maybe I have, or maybe an array of actors, if that is a structure in itself. I may have the director's name, I have a year, I'll have a title for the movie, that sort of thing. How about the pixel, or a pixel, not a pixel phone? I have one of those, but pixels on the screen. What is a pixel? Well, a pixel on the screen is just where it is on the screen, an X and a Y coordinate, and a color. Now, that color could be represented as a number, like an RGB color, but we can go even further than that. We'll be looking at that soon. But I want some nice clean way of calling a function. I want to be able to cleanly and easily pass information around. I don't want to have to pass in 20 different variables. If I want to draw a pixel on the screen, I want to pass in the pixel, not an X, a Y, and a color, because that is kind of clunky. I want to arrange data and keep them together, bundle them up. So this is what the idea of a C structure is. I could not find a really good example of this. It's essentially you're going to duct tape a bunch of data together. You're just going to, okay, take this data, bundle it up, put some duct tape around it, you're good to go. Right? That's what we're trying to get to. So a bunch of related data like your student ID, like your name, like your GPA, you wrap them up together, you say that's a student data structure, and then you can just refer to that particular student and then get the individual fields from that student. It can contain, so unlike an array, it contains data from different data types. It can have a string, it can have an int, it can have this, it can have all integers if you want, but it is an aggregation or grouping of a whole bunch of data together, like duct taping a bunch of data together. And you access the individual thing by the name. You say student1 dot name, and that's the name for student 1. This data structure, all of that data gets bundled together. It's contiguous. It's in memory in the same place. All that data is in the same place in memory. And so instead of an integer, which is just a 32 bits of information, it might be 32 bits of information, 32 bits, and another 32 bits, and another 32 bits. It's all of those things all in one, just sort of wrapped together. And this one thing allows us to do an incredible amount of stuff. You just may not realize it yet. So we can do things like data structures where we have stacks and queues and linked lists and trees. A lot of these data structures that you can do in other languages, this is how you do it in C. You don't have objects in C, but a structure allows you to bundle together common data. This is essentially make your own data type. You're not satisfied with an integer, you can make your own data type, which is a bunch of integers and things together. So here's what it ends up looking. Here's what declaring a struct will look like, right? I have a struct, the name of the struct, and then I will put in what the various elements for my struct are. And then I will have a semicolon at the end. These elements can be anything, including other structs or arrays. It can be anything in there as long as it's already defined. So I have a point structure that I've already made. That was one exercise, so I should have actually wiped those out. Let's do the line structure afterwards. So by the way, I said RGB could just be a number. Here's RGB defined as one character or one byte of data for the alpha, the red, the blue, and the green. I could make a structure which is the RGB value, and I could have it be exactly 0 to 255, 0 to 255, 0 to 255, 0 to 255, right? How an RGB value is recorded currently in most systems, right? And I could pass this RGB value into something that has to draw images, right? I don't want to use just an integer because it doesn't break down. Like, I want to be able to separate the various component colors. Here is a point structure where I have an X and a Y position. And this allows, if I could have a 3D point structure, which would have an X position, a Y position, and a Z position. What would a line structure look like? Well, let's think about this one. First of all, let's see if I have an answer already made up. Nope. Okay. So what would a line structure look like? Well, it's going to be struct. So you should pause the video now if you haven't done this already. Struct. I'm going to call it line. This is the name of my new data structure. And by the way, I could put let's put the curly braces on the new line, because I've been been chastising you guys for a while about that. All right. And what defines a line? 2 points, actually. So I could make a data structure that uses the data structure I defined the line before. Or I could put 4 integers in there and have x pos 1, x pos 2, y pos 1, y pos 2. Have 4 integers in this data structure instead of 2 points. Both would be fine. It depends on how you want to define this. All the struct says is this new data type that we're going to have is just a bundling together, an aggregation of existing data types that we have, so that when you pass in a point, you pass in the 2 integers. I only need to pass in one variable, the point, but it automatically has 2 integers inside of it. Okay. So again, note the semicolon at the very, very end. I have my structure here. I open my curly brace. I close it down here. Put a semicolon. This, for example, this student data structure has an email address, a name, an ID, your student ID, and your grade point average, right? And so if I wanted to do something with this, I could just, if I want to pass a student, I just pass in this student data structure, let's say student S, and I pass in s into my function. This, by the way, does not make a student for you. This is like the blueprint of a building. It does not make the building. Just because I have a blueprint for a building does not mean I have a building. It's just the blueprint. It's how you would design the building. This is when I make a student, this is what it looks like. This is the format. This is how things look. That's what we're doing here. When I make one, it will have an email, a name, an ID, and a GPA. That does not mean this does not make that student. It just says what every student should look like. Okay, so this is just the blueprint, and then we actually have to make students later. This is not declaring a new student. This is how they're built. So here I have, again, I am making this is the blueprint for what a student will look like from in my case. Okay, this is me making a brand new student named David. This is how I would create a new student. Same as int I or int counter, right? We just make a new integer named counter. This is making a new student named David. This is me making 3 different things. I am making a new student named Jonathan. That's my son, by the way. I'm making an array of 20 different students. This would be an array of students, in case you can't see that, right? I'm declaring all 3 things at the same time. And this is making a pointer, a student pointer. It's called P Jonathan. Now, we're not going to get to pointers yet, so you can ignore that part right now, this part right here. But the other 2, this is an array of 20 students, which would define a class of, the student class. So I could say class at position 1, what student is that? So I can do it this way. So here's my blueprint, and I make them afterwards. I could even make those instances immediately after making my data structure. So here I've made my student data structure, and immediately I make an object or a struct called Ben, my other son, an array of 20 different students, group, and a pointer to Ben, right? I can do it immediately after making the structure. Notice the semicolon is now positioned right here. Or I can make them afterwards. I tend to make them afterwards. I like being able to break down my problem later. So I want you to try this exercise. I want you to define a structure to remember information about a rectangle. So this is our general blueprint. You can use any struct we've already defined, but what would define a rectangle? If I'm drawing a rectangle in space, let's say, like on the screen, what would define it? Well, I could say the bottom left corner and the upper right corner. The 2 points would could define a rectangle, maybe a color. I could define it as 4 different points. That's not a good way because it's a rectangle. It's not just some polygon. It's a rectangle. So I really only need 2 points. Or instead of 2 points, what else could I have done? Well, I could have done an X position, the lower left, and then the width and the height of the rectangle. That would also define a rectangle. There, you can translate one to the other. I have 2 points, or I have the minimum point and then a width and a height. So that also can define a rectangle. Whatever you want. The question is, how would you define a rectangle data structure? So give that a try, and we'll go to the answer in a second. And this is just an example of how a struct actually looks. Hopefully you pause the video. Okay, let's try this out. This is one of the ways you could have done it, right? I have an integer x, an integer y, a width, and a height. That's actually how I've written the rect structure 1,001 times. I could have also, do I have the other example? I could have also, or let's call it rect2. I think I call it point. And we've already defined a point data structure on previous slides where it was an x and a y coordinate, right? I could define a point structure and just the rectangle could be defined using 2 points. That would also be perfectly acceptable. Notice it looks exactly the same as the line data structure. The difference is I'm saying this is going to be done as thought of as a rectangle. This one's going to be thought of as a line, but they both use the same data to define themselves. 2 points, essentially. I could have also thrown an RGB value into this thing. So let's create a single rectangle using this structure here. This one right here. So how would I make an instance of a rectangle? So my R. Well, it's going to be rect my R. That's it. It's not going to set the values for me, but I'm going to have an X and a Y, a width and height. And they're just going to be whatever the default values are. So I think probably the CCCCC values that we had. Maybe it's 0, 0, 0, 0. If I want to make an array of 8 rectangles, the array is called R. What do I do? Well, I could call, so it's going to be called R, so it's going to be rect R square parentheses and then an 8, an array of size 8. An array of size 8. So it's going to be 8 different rectangles, one after the other. In case you're wondering, so I don't know if I'm going to be changing my Chinese zodiac homework question. I like it as a homework question. It gets to play with structures and you get to play with dates a bit. Don't overthink the Chinese zodiac question. If you're looking at it right now, it's not meant to be hard. You're not supposed to be going online to figure out exactly what the Chinese zodiac dates are. I'm saying they start on, I think, February 2nd. But what we want is, maybe we want a birthday structure, right? So that or a date structure. So it has a day, a month, and a year, and you could pass that in. So you could pass in a birthday structure or a date structure to the function, and it will return what your zodiac sign is. Are you a dragon? Are you a pig? Are you a rat? And you can also do that with other. So, why might I want to do that? So that's the other part of the question. I might want to do this because I don't want to have to pass in 3 numbers every single time, right? I want to just pass in a birth date structure. And if I change how my birth dates are being defined, I don't want to have to change every one of my functions to add other parameters, right? Maybe my birthday function has the time of my birth as well. I don't have to go through all of my code everywhere and change it up so that I have all 4 values instead of 3. I just want to pass in, yeah, it's this birth date structure, or this date structure, and it'll tell you what zodiac sign you are. This really conceptually simplifies what you're doing. You don't have to pass in 4 variables. You can just sort of bundle up similar ideas, similar data, like your student information, into one thing, and then just pass the one parameter into a function, or have that one parameter returned from the function, which is really important. Because before I could only return like an integer or a character, but I couldn't return multiple pieces of data. Now I can. If I have a structure, I make a structure with those. If I want to return 2 integers and a character, I make a structure that has 2 integers and a character, and I return that structure. Instead of, I can only return 1 item. So here's a payroll structure. Here's another example. So I have an employee name, I have an employee number, I have their number of hours they've worked, their pay rate, their gross pay. And here I'm making a department head, which is just one instance of payroll. Here's what the department head structure will look like. It is just all of those variables, these 5 variables, one after the other, and I'm accessing it. I'll show you how we can access the individual variable when we do this. But essentially, it's just one giant chunk of memory that gets passed around or gets evaluated or looked at. So from there, here is I'm going to make a department head, a foreman, and an associate. Fine. So when I make these 3 different payroll structs, here is payroll struct 1, here's payroll struct 2, here's payroll struct 3. How I access, if I say department head, which is the name of one of my payroll structures, it's this one right here. If I say department head dot hours is equal to 17, I will go to this field right here and put the number 17 in that box. If I said department head dot employee number is equal to this, I could change the employee number, or I can change the gross pay. I can access individual parts of this, individual fields within the struct by just putting a dot after the name of the struct I'm using. So, with that being said, I'm going to start up a quiz. Try it out. Hopefully it'll make sense. We're just trying to make sure that you understand what I'm talking about when it comes to structs. We're going to pick up structs in about 2 seconds. So pause the video, take the quiz, and come right on back. Okay. So actually what we're going to do is I'm going to stop this video, and then we'll take a little mini break, and then we'll look at how to access individual fields a bit more, and how we can have arrays of structs and structs of arrays. All right.